Welcome, everyone. Today, we are diving into a critical topic for any modern data organization, securing and governing your AI capabilities. We will learn how to use Snowflake's native role-based access control, or RBAC, to strictly govern who can execute Snowflake Cortex AI functions. Let's get started. Let's set the stage. What exactly is role-based access control in the context of Snowflake AI? In Snowflake, security is built into the DNA of the platform. You never grant permissions directly to a user. Instead, you grant privileges to roles and then assign those roles to your users. When we talk about AI, specifically Snowflake Cortex AI functions like complete, extract answer, or translate, we are dealing with powerful capabilities that process data through large language models. Naturally, you don't want just anyone invoking these models on any data. Snowflake uses its native RBAC model to govern these AI functions. Access is controlled via specific database roles stored in the shared Snowflake database. By mastering this, you ensure that your AI initiatives are both powerful and secure, allowing innovation without compromising on governance. Take a look at this diagram. It illustrates the core concept of Snowflake RBAC applied to AI. On the left, we have our user. The user is assigned to a custom role, perhaps data analyst or data scientist. That custom role is then granted a very specific database role, Cortex user. It is this final link that unlocks the ability to execute Cortex AI functions on the far right. Break any of these links, and the access is immediately revoked. Why should we care so much about governing who can run AI functions? There are three massive reasons: cost, privacy, and compliance. First, let's talk about cost. Cortex AI functions consume compute credits based on the number of tokens processed. If you don't govern this, a junior developer could accidentally run a 400 billion parameter model against a billion row table, burning through your budget in minutes. Second is data privacy. LLMs are powerful pattern matchers. If a user shouldn't see PI, they definitely shouldn't be running AI summarization on it. Finally, compliance frameworks demand a least privilege approach. You must be able to prove exactly who has the keys to your AI engine. RBAC is your primary defense mechanism against runaway costs and compliance violations. This flowchart highlights the stark contrast between ungoverned and governed AI. At the top, ungoverned AI inevitably leads to budget overruns and severe privacy risks. However, by routing your architecture through Snowflake's native RBAC at the bottom, you achieve predictable costs and auditable compliance. It transforms AI from a wildcard expense into a tightly managed enterprise asset. Here is a crucial piece of knowledge that catches many architects off guard. Out of the box, Snowflake wants to make it easy for you to try AI. Therefore, the primary database role that grants access to Cortex AI, called Cortex user, is granted to the public role by default. Because every single user and role in your Snowflake account automatically inherits the public role, this means everyone has access to AI functions on day one. The same goes for the use AI functions account level privilege. While this is fantastic for a sandbox environment, it is absolutely unacceptable for a production enterprise environment. As a data architect, your very first move when operationalizing Snowflake Cortex should be addressing this default open door policy. Look at the visual representation of this default state. The Cortex user database role is flowing directly into the public role, highlighted in red to indicate a security risk. From public, access cascades down to Alice, Bob, and Charlie. Regardless of their actual job titles, they all have the keys to the AI engine simply because they exist in the system. So, how do we fix the default state? We move to a zero-trust baseline by revoking those public privileges. To do this, you must assume the account admin role the highest level of administrative power in Snowflake. From there, you execute a simple but powerful command: revoke database role snowflake.cortex user from role public. You will also want to revoke the use AI functions privilege from public if you want complete lockdown. Once you press enter on these commands, you have successfully shut the open door. No one in your organization can run an AI function unless you explicitly grant them permission. You've just taken back control of your compute credits and your data security. This sequence diagram walks through the remediation. The account admin issues the revoke command to the Snowflake database. The database immediately severs the connection to the public role. As noted at the bottom, the general user base is instantly blocked from running AI functions. The foundation is now secure and ready for custom role building. Now that we have locked the system down, we need to carefully hand out access based on actual business needs. Snowflake gives us granular database roles to do this. First, you create a custom role, like AI Analyst. Then, you choose their level of access. If they need to build chatbots, use Cortex Search, and run all LLM functions, you grant them Cortex User. But what if they just need to run simple sentiment analysis in SQL? You can grant them the AI Functions User role instead, which allows scalar functions, but blocks heavier services like agents. There is even a Cortex Embed User role just for creating vector embeddings for RAG architectures. By matching the database role to the exact business need, you enforce the principle of least privilege. Here we see the decision tree for a security admin. After creating the AI Analyst role, the admin reaches a decision point. They can route the permissions to full AI, scalar only, or embed only. Whichever path is chosen, it converges at the end where that highly tailored custom role is finally granted to the end user. It is clean, modular, and highly secure. Let's go one level deeper into the architecture. Governing the functions is great, but what about the models themselves? Running a 7 billion parameter model costs significantly less than a 405 billion parameter model. Snowflake allows for model-level RBAC. This means you can dictate exactly which models a user is allowed to pass into the AI complete function. To do this, an admin refreshes the base models in the Snowflake.model schema. This automatically generates specific application roles for every supported model. You can then grant the Mistral 7B application role to your standard analysts, while reserving the massive, expensive Llama 3.1-405B role strictly for your senior data science team. This is absolute, surgical precision over your AI spend. This graph brings model-level RBAC to life. The data scientist role on the left is granted the application role for the 405B parameter model, allowing them to do heavy lifting. Meanwhile, the basic analyst on the right is explicitly mapped to the Mistral 7B application role. If the basic analyst attempts to call the massive model in their SQL query, Snowflake will block it instantly, protecting your compute budget. Let's apply everything to a real-time use case that you might encounter tomorrow. Imagine a global retail company. The marketing team needs to analyze product reviews for sentiment. Simultaneously, the data science team is building a complex retrieval-augmented generation chatbot using Cortex Search. If left ungoverned, marketing might accidentally use an expensive model to process 10 million reviews. To solve this, we implement a tiered enterprise AI strategy. First, we revoke access from public. Next, we give marketing the AI Functions User role and restrict their model access exclusively to the smaller, highly efficient Llama 3-8B model. Finally, we give the data science team the full Cortex User role and access to all models. Marketing gets their insights cheaply, data science gets their power, and security is maintained. In this real-world flow, enterprise data hits our RBC routing logic. It smartly splits traffic. The marketing role is directed down the highly constrained, cost-efficient path using smaller models for scalar tasks. The data science role is directed down the unrestricted path, giving them the broad capabilities needed for advanced RAG development. It is the perfect balance of enablement and governance. To wrap up, remember these core tenets. Start with zero trust by revoking AI privileges from the public role. Always enforce the principle of least privilege by choosing the exact database role your users need. Don't just give everyone full Cortex user access. Actively manage your compute spend by leveraging model-level RBC to restrict massive LLMs. And finally, constantly monitor your environment using the Cortex Functions Usage History View to audit token consumption. By mastering these concepts, you become an invaluable asset to your data team. I invite learners to like, subscribe, and visit quicktechie.com for premium certification prep, including Q&A banks, full ebooks, audiobooks, full-length training, and interview guides. This mind map serves as your final checklist for AI governance in Snowflake. Your foundation is zero trust. Branching out, you must apply least privilege via granular roles, strictly control costs through model RBC, and maintain rigorous auditing using Snowflake's native usage history views. Keep this map in mind as you architect your solutions.